a few things to talk about. We're talking about degree structures, parallels, declinations, and retrograde, and the nodes and retrogradation. So we're just going to be going through a bunch of things, and the whole purpose of these classes is to expand our concept of degrees. We're just looking at a chart. We see the degrees going around the chart. We see there's a little degree around the chart, so it's this little portion of the circle, and it's much more than that. It takes a while to get your astronomy sense connected to the astrology chart to just get to be able to see that, to see the chart in its three-dimensional format. So today I want to start with talking about the degrees, and this is from an article I did a number of years ago, but the drawings, the graphics are what I wanted to use. So when we look at degrees, if we look at it, here's the sun, here's the earth, here's this circle of zodiac. We make the zodiac as a circle around the earth. And really, it's really and we consider the sun moves around through the zodiac, but because the earth moves in an ellipse around the sun, that's why there's a number of days in each season, a different number of days in each sign of the zodiac. The sun moves, when you're looking from the earth, the sun moves at different speeds through each degree. So when we, and this is a drawing here, we see two exaggerated 1 degrees, but when there's a 1 degree, when the earth is furthest away from the sun, that's going to, on one side it's going to be like here the earth is closer to this, there's 1 degree from it, but when you look from the earth going towards the other side, it's a much bigger example. You know, you see the ellipse, one side of the ellipse, whichever side the earth is closest to. Well, the earth is part of the ellipse, but when this was just looking at the idea of planetary ellipses and degrees, I just drew this to draw the idea of there's different, 1 degree becomes different sizes as the further out it goes. And when you have a closer part of the orbit or further part of the orbit, 1 degree for the sun being at different sections will be, it'll take more, it'll move faster or slower through that 1 degree. So spend more time in that 1 degree or less time. So that's why we use ephemeris. It's not just the same amount. That sun doesn't, the earth doesn't move the same amount every day. It kind of does, but as it's moving through the degrees, it's moving different amounts of space, different speeds. So, okay. So when we have, I'm just going to follow the notes of this for a little bit. 1 degree of longitude contains 100 degrees of latitude. So we have 1 degree of longitude, but there's also a north and south. So that 1 degree is only 1 degree, but it's like a slice of a pie that goes all the way up to the pole and all the way down to the next pole. But when you're first working with the degrees, we use the circle more than the ellipse. So when we see, here's an example of here's the sun in the center, the heliocentric circle of degrees from the sun. Really, it should be where the earth is while we watch it, but this is just to show example. At the sun, it's a degree is a small thing at the surface. As it gets out, it's a bit more. But as you get to the earth, 1 degree has a much bigger difference. And if the earth were closest to the sun, it would be a much shorter distance and move faster through that degree. But when we're using a zodiac, we use a circle which makes equal degrees, but it means the planets and the sun or the earth and the moon, they move through the degrees at a fluctuating speed. They might have an average movement a day, but really they're covering different amount of spaces, a different amount of distance. They're closer or further from the sun in different degrees as they're moving around. So there's different textures and different meanings of what's happening within a degree. So what I'm trying to get here is there's this, degrees are space, like it's degrees of space and time. They're It's more than just a little arc on a couple of notches on a circle. There's relevance and significance and space in every one of the degrees of the zodiac. So this is the same one again. It shows the 1 degree being different sizes. Okay, so this is the north and south view. If we took 1 degree and looked at it edge on, there's the ecliptic right in the center, sun in the center. The Earth sun line would be that center point. We mark off 1 degree, and it goes all the way 90 degrees up to the North Pole. The ecliptic, not the Earth's North Pole, the ecliptic north, the North Pole of the ecliptic, and the North Pole, the South Pole of the ecliptic, which is somewhere in space. It's not our pole of our equator, the Earth and the equator. But still, this is a degree. So a degree not only is occupying a distance in space going along the orbit or along whatever circle you're measuring or orbit plane you're measuring, it also has an up and a down, a depth. And there's different layers of depths. And basically, all the planets move within 7 degrees of the sun, or of the ecliptic. So the sun, moon, and the planets all are within the 7 degrees north or south of the ecliptic, except for Pluto, which can go a little bit further, go more further. So when we have that ecliptic, we have not only what makes each degree different. One, it's distance from the sun, the section of the zodiac is in, the light and the dark that's happening when the sun goes through that degree. But really, there's different stars in each degree. There's different size stars, bright stars, light stars, different stars, and they're in different proportions going north or south from that degree. And this adds another type of light, different color, different light, different size, a certain amount of matter or space that's in each degree. Okay, so here's just some considerations. I'll read them off here. Let's see, if it's not the sunlight that renders the degree of each degree of the zodiac meaningful, perhaps it's the starlight. Well, we know that the sun moves through each degree and it gives light for part of the year, for 1 day. It's just going through that degree. So each degree accumulates a bit of sunlight in it. It's like if degrees have memory, for example, they accumulate everything that happens in that degree. They're looking up from that degree and accumulating and absorbing. Every time the sun goes through, it adds that much light to the degree. Every time the moon or any planet goes through there, whoops, there's another experience happening in that degree. It's accumulating data. So there's, if you're looking at starlight, there's a total amount of starlight. So you can say how bright, how many stars, the number of stars, but there's how much light is actually there from the combination of all the stars. So the quality, intensity of the stellar brightness, how bright, how dark. There's a color composition of each star within each degree. So there's shades of color and textures of color and different quantities of color within each degree. And the quantity of stars within each degree and the actual mass or celestial mass of each star, of each object, of everything within that degree. Now, the universe is moving, so these things are fluctuating, but when you were born, each degree has substance to it. It has matter to it, it has stars in it, has light, it has color, and it has different textures within it. Yeah, it may seem it's a very subtle level, but it's a whole other level of frequency, and as planets go through these different colors, it adds its energy to those colors, and we're finding degrees of significance. It has relative degree of significance. Everything has an effect. It's not that they can be, these can be met, these are measurable things, but it requires, now with computers, we're getting to a place where we can do this, adding color and adding, so the mass can be done fairly easily. The color of each star, they have the colors, they have the color spectrum of the stars and that, but how to add them quantitatively is still a puzzle. I paused at that point. I have some research in that direction. Also, you can involve the distance of the Earth from the sun in each degree, the amount of time the sun spends in each degree, the amount of heat deposited by the sun in each degree, the amount of space the Earth travels amount of space Earth travels through each degree, or each planet travels through each degree. So there's, in 1 degree, there's a lot of stuff going on. Every star, all the stars and skies with it, different first magnitude, second magnitude, third magnitude, fourth, fifth, sixth, and there's different combinations of them. Some degrees have no first magnitude stars, some have 2. So like, they fluctuate, and some have second in different amounts of them. But when the sun's in a degree, it could be argued, because its light is so bright, you won't see the other stars. The starlight's still there, the energy's still there, the space is still there, the feeling of the degree is there. It's just there's extra light that's closer that's coming in to impress us within that each degree, which happens once a year, once a cycle. So the basic idea out of this whole little process was that you have the degrees moving out from a point in a circle, and they get bigger and big. There's still 1 degree, but 1 degree at the surface of the sun is really different. It becomes thousands of miles or more, way more, as it gets out to the orbit of Earth, and then it becomes millions of miles when you get out to Saturn or Uranus or Neptune. 1 degree, and all the things that are. By the time you get out to the stars, you're measuring a huge, vast area of space. Okay, this one. Okay, into the second one. Okay. Okay, so we're going to continue with the degrees. This has a drawing of this puts the equator parallel and puts the ecliptic on its angle of 23 degrees, 27 minutes on the angle. You know, so that's why the Tropic of Cancer, Tropic of Capricorn, the equatorial zone, the Tropic of Cancer is 27 from the pole. They all these factors are interwoven with each other. But when you have a degree, we'll do this further, but this showing a degree on the ecliptic, first degree of Aries, for example, and the first degree of that would be of Aries in the equator are 2 different things. So this is a puzzle. The houses are measured on the equator. There's straight lines coming off the equator. We're going perpendicular to the equator, but the planets are moving, the zodiac and the planets move through the ecliptic. So there's a puzzle here that I want to try and explain a little bit better. Let's see, would it be? Yeah, so we have degrees on the equator, degrees on the ecliptic plane, and they're different. They're unique, but they all have a north and south pole. So in the equator, if we're taking the equator, we have the Tropic of Cancer, we have the Tropic of Capricorn, the sun's highest point and the lowest point, 23 to 27 degrees north or south. And we have the North Pole, the South Pole, but there's a when here there's a picture of when the sun's at the Tropic of Cancer. The sun's at its highest point north. So when the sun goes north of the equator, it begins not to be seen at the southern point in the Antarctic Circle. So there's part of the degree gets darker and the other parts get hotter as you're going north, because they get light all day and all night up in the Arctic Circle as the sun comes north of the equator. So when the sun's in the ecliptic, it's shining both. It reaches both poles.